Hello everyone, today we'll be moving on to lines. This is in a three-dimensional space. So how do I describe this line? Let's say I know a point A on this line. So what I can do is find the position vector OA. Okay, but how does that help us? We can make use of this thing called a directional vector. So what this directional vector is a vector that is in the direction of this line. So let's say I have this vector 1, -2, 2. Which is in the direction of this line. Now how does that help us to find the entire line? If you see, let's say I multiply this directional vector by 2, I get 2 times of 1, -2, 2. And this is what happens if I multiply it by 3. I get 3, 1, -2, 2. I can even multiply it by a negative number. Let's say -1, 1, -2, 2. And get the other side. So what we can see is if we have any multiple, let's call this multiple lambda, what we can see is if we multiply this directional vector by a constant, let's call this constant lambda, I can get all these vectors over here. This vector, this vector, this vector, this vector, this vector, this vector. All of these are derived from some lambda of 1, -2, 2. If you remember, if we add OA to any lambda 1, -2, 2, which basically gives us all of these possible vectors here. Adding this together will give us the resultant vector, be it over here, over here, over here. Basically anywhere on this line. And as such, this will give us the position vector of every single point on this line by varying this value of lambda. This is what we call the vector form of the line. R, which is the position vector of all the points on the line, will be equal to the position vector of any point on the line. So let's say OA, or let's say if we have another point, maybe let's say D, we can use OD. So this is any position vector of a point on the line. And here is any directional vector. What we want to do is take lambda. Over here we define lambda as any real value such that we can find every single possible vector here and then get every single possible point on the line. This is what we call the vector form of a line. Next, we're going to look at two other forms, the parametric form and the Cartesian form. First of all, the parametric form, this is in the formula booklet by the way. We will take x equals to a1 plus b1 lambda. That is just x equals to a1 plus b1 lambda. And xy will be a2 plus b2 lambda. And finally, z equals to a3 plus b3 lambda. Seems simple enough. And for the conversion from parametric to Cartesian form, what you want to do is make lambda the subject of the equation. So in this case, if we make lambda the subject of the equation, we'll get lambda equals to x minus a1 over b1. That's what we have over here. Over here, we have y minus a2 over b2. And we equate it over here, and same for z. So all of this will be equals to lambda. But usually, we don't write the lambda. What we'll write is just this over here. Now, let's do a question. Find the vector equation of the line passing through these 2 points. Again, revision. These 2 points are just 3, 2, -1, and 4, 5, 10 in terms of column vectors. We want to find the vector form of the line. That means we need one position vector and one directional vector. We already have 2 position vectors here, so actually we can use any one. But to find the directional vector, let's visualize this a bit. Let's say we have OA as 3, 2, -1, and OB as 4, 5, 10. The directional vector is just AB over here. And how do you find AB? Vector AB, if you remember, is just vector OB minus vector OA, which is 4, 5, 10 minus 3, 2, -1. And this will get us 1, 3, 11. So the vector equation of this line is just R equals to any one of these position vectors. Again, we can use either one of these. In this case, I'm just going to use 4, 5, 10 because why not? And then plus lambda times the directional vector. In this case, 1, 3, 11 is a possible directional vector. Let me ask you a question. Let's say I find vector BA instead by taking 3, 2, -1 minus 4, 5, 10. Is this still a possible directional vector? Yes, this is still a possible directional vector because vector BA is still in the direction of this line.